George's idea to make a table to illustrate our experiment, and I thought it would be good to give the table a feature so that people would not just look at it and walk away, but it would invite them to sit down and to do something participatory. Because a lot of people look at public art and just wander off after a few seconds, so we really wanted to pull people in and have them sit and consider the piece. George's work is to do with the preservation and conservation of stone in buildings and monuments, and my work as an artist is basically to trick people into staying a little bit longer and looking a little bit closer at the sculpture in question.
We decided that we would certainly do something in stone and try to create something that would reflect the life cycle of the stone. How it starts as a raw material and it's turned into a work of art that matures with time, but then eventually begins to degrade. Many of these conservation problems are beautiful problems in material science because the fundamental problem isn't obvious. So it requires some investigation. And very often the cause is very subtle and involves interactions of lots of forces. So you have to think seriously about what's going on, and you often have to devise novel experiments to tease out what's really going on in order to find the solution to the problem. So it's detective work, and that's what we enjoy.
His work does extend to the realm of art, absolutely, but it's not, art making, it's art preserving.
Fundamentally, the science that controls the deterioration of works of art is the same as that controls formation of potholes. So we could work on either one and serve the interests of the other community. As you can imagine, students are more excited about working on conservation of art than working on prevention of potholes. So particularly with undergraduates, it's a very attractive field.
We put this piece in together, and I think that was very valuable for his students to see because they all showed up and participated as well. And it's a lot less static than taking a tour of a building, which is built, and you're looking at the effects of time and how to mitigate those. But we were doing something that was intentionally quite impermanent at first, and it was a very galvanizing experience actually to bring the scientists and the artists, and that I think was part of the function of Quark Park, was this whole synthesis of fairly brilliant people working on a pro bono basis to make something interesting and vital for the community.
The two legs will be immersed out of sight underground into a pool of a salt solution, which will be rising up by capillarity, the way a sponge sucks up water. The liquid will rise up into the stone and salt will begin to deposit in it. And we've treated one of the legs with a solution here we can talk about that protects it, and the other we expect to start to degrade. So that you'll see that the life cycle in fact goes from the raw material through maturity and then finally to deterioration. And on the other side, it'll be protected from the same thing. So the goal of our research course is to delay that deterioration and extend the maturity and the period of beauty and utility of the work. In this case, this is sort of an unusual connection because very few people associate science with art. So anything that makes people realize that science is entertaining as a career and valuable socially is a good thing. Almost every little kid wants to be a scientist. Something terrible happens along the way, and I don't know what it is, but we have to address it somehow. I'm hopeful that the attraction of the beauty and the inventiveness and the curiosity of these installations at the park will attract people in. And it will not be the science that draws them in, but the beauty and the oddness of some of them. And once they're in, we hope they'll turn their attention to the underlying scientific ideas that inspired the work.